Hey guys, good evening. I hope I'm pretty much audible as well as visible. Right, so just to let me know if I'm audible as well as visible, guys. I'm trying to set up the things here. So just a quick hi or hello in the chat would be really great. Uh, okay, cool. So thank you so much, Akash. Good evening. Great, thank you for joining us. I hope others are also joining in. So great. So let's quickly start. So again, welcome everyone in today's discussion. So we are into a playlist which is data analysis in 3 weeks, and today's topic is Seaborn complex plots. So we'll be going deep in different types of plots we have in bivariate. So we have started with the bivariate analysis yesterday, and then we discuss about some of the good graphs like joint plot. And in joint plot, we have multiple options. We were discussing about something in relational plot, right? So today also we'll continue from there and we'll discuss what all different available graphs we have. So that's what the agenda pretty much is for today, and we'll be doing that. Again, as always, it's pretty much a live session, guys. Any questions regarding any topic we have studied so far, or anything in general as well, which you feel that you want to ask or you might have missed out, so do let me know in the chat. I'll take that. Okay. So again, I welcome everyone in today's discussion, which is data analysis in 3 weeks. That's our playlist, and we'll be covering the C1 complex plots from your bivariate analysis. That's the topic for today. Okay. So before starting, I'll introduce myself as always. My name is Arpit Jain, and I'm lead data scientist myself. I have been working into industry for almost 9 years now, into multiple domains, be it finance, automobile, manufacturing, telecommunication. So I've been into multiple fields. So if any questions regarding any specific domain, I might not be able to answer everything, but still I'll try to answer them to the best of my knowledge. But still, any concerns regarding data science, job, domains, do let me know, guys. I'm also a motivational speaker, so I talk to students regarding their placements, regarding their career. I do career counseling. I talk to, I take kind of industry sessions. So anything which is in general also related to your placements, job, careers, anything which you want to talk, right? You are confused about. So do let me know in the chat. I'll definitely try to take that here as well. Hey Vasanta, good evening. Thank you for joining us. So that's pretty much it, guys, about me. Again, as I'm repeating it, let's try to make this session interactive. So, as I was talking about it yesterday, today I will be asking you questions in terms of how you're gonna read the graph, because somebody was saying this earlier yesterday, right? So, they're not able to understand, they're not able to read the graphs. Again, I'm telling you, Seaborn or whatever plots, whatever analysis you're doing, right? It's still somewhat easier to plot the graph because it's just a function, just a code, right? So, you can still plot the graph, but again, the core knowledge is afterwards. Once you have run the graph, now what? How are you able to read the graph? That is something which is very important. To take out the industry inferences, the business inferences from the graph is very, very, very important. Okay, I'm repeating this again. It is very important. So you have to be sure of what are you seeing from the graph. Okay, it has to be making business sense, and also you should be able to take some strategic decisions post graphs, right? So you have to be very sure of what you have plot and what that graph is showing you. So reading the graph, taking the industry inferences is very important. So we'll focus on that. And as I've said, so I will be expecting you to answer me those questions. I'll give you enough time for that, okay? But I would want you to be on your toes and really respond on the chat. So I hope this is pretty much clear. Okay with everyone, Akash, Santa, and whosoever is part of our chat today. Let's try to do that, okay? Let's try to interact, because again, if I show you some 10 graphs, it does not make any practical sense if you don't understand how to read the graph, right? I mean, just adding few things in your resume likewise does not really make sense if you don't know it, right? So know one or two things, I'm fine with that. But again, whatever you know, you should be knowing it to the best of your knowledge, right? So try to ask questions if you do not understand the graph, if you're not able to read out the graph, okay? This is very important. So please mark my words, to ask questions in the chat, okay? Proceeding further, I'll just open up the content slides. Give me a minute. This should be pretty much here. Just give me a minute, guys. I'm trying to set up this. Okay. Right. So I hope my screen is pretty much visible to everybody. Right. So we were talking about the joint plot, right? So remember, so joint plot is part of my bivariate analysis where we are doing both there are three types of joint plots which we can do. So we have scatter plot by default, then we have hex bin plots, and then we have the KDE plots, right? So we know, so my joint plot from the scatter gives me the a kind of a correlation between my x and the y axis. So what is the trend, right? But on the other hand, my hexbin plots and my KDE plot is giving me the density, how the data is spread out, where is more density, right? So where the number of data points are higher. So this is giving me that information, right? So every graph has their own objective. So we have to understand when to plot what, right? This is very important, and you will only understand if you will only get to know this once you have the information out of what you're trying to plot. Okay, so that's basically what we have to do. Great. So starting from rel plot today, right? So relation plots. In the relation plot also, as I was said, so we have two options here. Again, the same parameter kind. So we're going to use both the scatter plot and the line plot. Okay. So we're going to be doing that. Okay. Now how? Let's look at this scatter plot and line plot. Okay. So here we have loaded the tips data. And you remember we were talking about total bill, tip, sec, smoker, day, time, size, right? So we discussed about this yesterday. So here we have observed some of the very common, even before plotting the data, we could assume, we could still sense out of it, right? So as long as my bill increases, yeah, the tip should increase. I mean, it's not a direct correlation, but again, there's a high probability that if the bill size is high, tip could be high, right? Because I'm not going to pay, as I said, 50 rupees for a bill of 10, right? I will pay maybe 50 rupees for a bill of 500. So yes, so bill tip increases as long as my bill increases. Likewise, there could be a relationship between my the gender, male and female, and the tip, and also could be in the days of weekday, weekends kind of a thing. Dinner or lunch also could be affecting. Even the family size, maybe a family, a bigger family, a bigger group going for a dinner may pay higher tip. Compared to a couple. So again, could be a lot of things which we can sense from this data, right? So this is what we started. We started with the basic rel plot using the kind of scatter. So I'm plotting a scatter plot here, and here we could see between total bill and tips, somewhat there is a positive correlation. I could see yes, as long as my total bill is increasing. I could see somewhat tip is also increasing, but it's not a very strong correlation. I could still see some outliers in this area. I could see that yes, even that bills are higher. Tip size is still not that substantially high, right? So I could see the positive correlation, but it's not a very strong positive correlation. That's what I'm able to see. Again, the same thing plotted on the line. So line here, I'm just giving the trend of how the things are being shaped up. So on top of this, we added one very interesting argument here, hue. So here, yesterday we talked about two different arguments. One is hue and other is call. Okay. So what hue and call is doing? Hue is basically adding the third dimension to my analysis. Okay, so that's what hue is doing. And then what call is doing? Call is again doing the third dimension only, but making separate graphs for each new dimension. That's the difference. Okay, I'm just giving you very core definition, core meaning of these hyperparameters. This is very important. I'm telling you, these two are very good and interesting hyperparameters. So now on the same data, X is total bill and Y is tips. I just added another argument, hue. Hue is like I'm adding a third dimension to my analysis, right? So what I'm adding as a day, for example, I want to know how the bill and tips are interacting on each day, right? So now here, can you see in the graph, Thursday, Friday, Saturday, Sunday are being plotted under different color combinations, right? So I have different colors or for each of my bill and the tip interactions. But we also observed that this graph specifically somehow is not that readable. So again, if you imagine that if you have all the days, so even for the 4 days, it is not that readable because there's a lot of overlapping here, right? You can see it's a lot of overlapping. But and even if you keep on increasing the granularity, the number of days is keep on increasing. The issue still again issue will keep on rising, right? So the graph will become more and more unreadable, right? So to cater this problem itself, we have another argument called as call. We can use the column call here, and it's going to add again the same third dimension, maybe in this case fourth dimension if we're going to use hue and call both. So it's going to be in that case, so it's going to be maybe a fourth dimension, right? And in this sense, what I'll be doing, so whatever parameter I'll be passing on call, for that parameter, I'll be getting the different set of graphs, different graph for each of my granularities. For example, if I simply do here, say call. So let me plot the same graph before doing this. So if I do it like this, I'm not sure if this is run. Just give me a minute. Let me load this up. Right. Yeah. So if I plot the same graph by giving, instead of call, hue, I'll give call here. So the difference you should be able to see here. So now in this graph, you are seeing that for here, if we have in the hue, in the same graph, I'm getting all of the information, right? So on the single graph, my different days are being plotted. But if I added call as day, now I'm getting separate graphs for each of my days, right? So again, this is pretty much unreadable. You can see this, the graph size has reduced. It's pretty much, again, not so readable, right? Again, we have another argument called as call underscore wrap. And I can make sure that instead of having all the 4 in single line, I can make sure that only 2 are getting plotted in a single line. So that will make it more readable, right? So I can do that. So now here, yes, it is pretty much readable, right? So I'm trying to show you what multiple things you can do in the same graph. So here you can see this. Now it is pretty much readable. So now I can see this on Thursday. Yes, there is a strong correlation. Friday, okay, the number of data points are very less. So maybe there are less people going for a dine out on Friday. It is very rare. I mean, generally you assume that Friday, Saturday, Sundays are more crowded, right? But again, there's a very strange inference which I could see here. I could see that the Fridays are not that crowded. Yes. On the contrary, Saturdays are the most crowded day, right? And also I could see that there are some very strong outliers here, right? I could see that the majority of my, the maximum payouts for the tips are happening on Saturdays. Yeah, so Saturdays are my party nights. Office going people, they go to party on Saturday night, right? And yes, the tendency to pay higher bills, to pay higher tips, it generally gets increases, right? So that's what you have it on Saturday. Sundays, yes, we still tend to have some party people around, but again, the tendency to pay higher, it's a bit lower on Sundays also because there is a Monday coming up, right? There's a sense of, again, that let's not spend too much, maybe it's office going to start. So something of that sort, you can try to make some story on top of this data, right? So here, this is very important, guys, very important to make some business sense out of this data again, right? So these are not some random point. These are not some random information here. You have to, once the data is plotted, you have to get the information out of it. You have to read how you can use this. What is the business inference out of it, right? Making sense to everybody? Anybody is having any concerns here? Are you able to make sense what I'm trying to convey here? Akash, Vasanta, and whosoever is part of our chat today. Is this point making sense? You are able to read this graph. You are able to see the distinctions in my patterns here. You're able to see the distinctions. Here you can see on Thursday, yeah, pretty much sober people, pretty much, a very constant relationship. So it's a very strong relationship, right? You can see comparative to Saturdays and Sundays where they're majority of my outliers. Sundays are my majority of my outliers. There's no relation at all, right? It's all haphazard data. But on Thursday, it's a very strong correlation. I could see that, yes, there's a strong correlation. As long as my bill is increasing, my tip is increasing, right? It's a very strong correlation on Thursday. But on Sunday, it's a very haphazard data. It's all distributed everywhere. There's no correlation at all, right? So this is kind of information we look out from the data, right? So now again, look at this. I've added one more dimension. So I've added hue and call. So now I've added the 4th dimension in my data, right? So now what I've done is, so I will still have this same information. I would still have the column as the call as day. So I'll be having different graphs for my day. But now on top of each of my different graphs, I'm also adding a 4th dimension, which is nothing but as my gender, so or my sex, right? So here I'm adding hue as sex. Here I'm trying to find out now also for each of my days how the male and female patterns are behaving, right? So you could see some really interesting inferences out of this. So now can you see this? Interestingly, on Saturdays, very prominent outliers are males, right? Can you see this? Very prominent outliers on Saturdays here where the tips are being paid more are males, right? I would also want to know whether these males are going in a group or these males are going in as a couple, right? So I would still, maybe an interesting thing now which we can try to analyze here is, are these people who are going in a group, like maybe in a office party or or family, or are these people going in a group of, say, as a couple or a smaller groups? Who are these people who are paying this? Again, we could get some more detailed information, right? So all of these information, ultimately, you are converting it to some basic business inferences, right? And now based on these inferences, you can take a decision. For example, suppose if I would see that there's a high probability that on Saturdays males are expected to pay higher bills, or males are expected to pay higher tips. Maybe I can give them a few more, maybe a free beer, right? So maybe if you spend $50, you can get one free beer, right? Or maybe, that's too cheap of an offer, but again, maybe you can get one large shot, right? So whatever, right? So again, these are some strategic decisions, because based on the analysis, I figured out that there's a high probability on Saturdays, maybe on dinner, maybe on evening parties, the males are expected to pay higher bills, higher tips, right? So I can give them some offer. I can try to attract them more, right? That's what the business sense here means. And how I'm taking that decision? Based on this outlier information, based on these 2 points, which is coming as my scatter plot, right? So this is what, as a data scientist, your job is. Your job is not only to run this graph and sit idle. Okay, now let people decide whatsoever they wanted to know. Your job is now starting. Your job is to tell me how to read this graph, how to make this use for my business. That is your objective. Making sense, guys? Cool? Great. So this is what we have done till date, right? So I'll just proceed further, and I will try to start with this. Okay. So I'll start with the pair plot today. So I just wanted to give you a brief of what my expectation is in terms of my graph and how we're going to plot that. But today, let's start with a new topic. So we start with pair plot. Okay. So pair plot is again one of the very interesting graph available in Seaborn, which is actually a pairwise relationship plot. Okay. Now, what is pairwise relationship plot? I'll tell you. So as I've said, so here in this data, how many points are there? So how many different data sets are there? So we have, for example, for the iris data set itself, we have 4 numerical column and 1 categorical column, right? So as I have said, here in this case, we can try to find out the relationship between all of my variables, right? So there could be a relationship between my sepal length for sepal width, and sepal length with petal length, and also sepal length with petal width, right? So all the 3 combinations are possible, right? Likewise, in the same way, even for the sepal width, it is pretty much valid for all of these 4 variables, right? So I can try to see for all the variables how the variables are, how the interaction is, right? And that is where pair plot is used. So pair plot is actually plotting you all the possible combinations of such interaction possible in your data. And it is plotting you all the interaction at the same time. Okay. And what it does, so this shows the relationship of n cross 2 combinations of variable in a data frame as a matrix of plots. So now here I'll be getting a matrix of plots like the way we were seeing here, right? So here is a 2 cross 2 matrix, something of that sort, right? So likewise, for howsoever combinations we have, right? So those many matrix of plots will be plotted for us, and the diagonal plots are the univariate plots. I'll show you what does that mean. So don't get confused by this. I'll tell you what do I mean by this. So here again, we have certain parameters which can be passed on top of it at the time of creation of my plot. So I have data. So I have data here, which is my data frame. And then I have hue as always. So I'll be plotting the different, again, the 3rd dimension to my data. Then I have palette, so which is my colors for mapping the hue variable. So exactly what color. So you remember, right? So we were talking about palette and aesthetics and everything. So we can pretty much do that. And then we have kind. So kind is nothing but basically my kind of plot for non-identity relationships. So we have scatter, we have reg, right? So that's what we can plot on kind. And then we have the diagonal kind. So I'll tell you for how we can use a diagonal kind as well. Okay. So now just look at this graph. This is very interesting graph, I'll tell you. So now here what I've done is I've loaded the dataset iris here. Okay. And now I've set the style as ticks for we have already seen this, guys, right? So we have seen the set style. What is set style? I'm setting a theme, right? I'm setting a theme for my graph here. So I'm setting that as ticks. Okay. Now here I'm plotting a pair plot, which is sp.pairplot, this function, right? And I have the data set df passed here. So all the numerical column from df will be passed for this creation of my graphs here. So all the numerical column would be what? So all the 4 columns: sepal length, sepal width, and petal length and petal width. That's what by default would be taken from here. Hue is species. So I've added a 3rd dimension here. So I want to see how the data set is behaving with respective to all of my categories also. So I've just added so as I've said, hue is pretty much one of those parameters which is pretty much available in mostly all the graphs. Okay. So hue we can use almost everywhere. So hue is species, okay, so that's what we add here. And then we have diagonal kind, okay, so diagonal kind means, again, by default diagonal is a diagonal plots, right? So as you know, in the diagonal plots, so we have, for example, in the x-axis you can see here sepal length and sepal width, petal length and petal width, so all the 4 columns here, right? Likewise, even on the y-axis we have all the 4 columns. So suppose this graph, right? This graph is for petal width and sepal length on the y and the x-axis respectively. Likewise, this graph, the second graph from the bottom row, will be what sepal width on the x-axis and then the petal width on the y-axis. Okay, so likewise this keeps on growing. So now for this particular graph, the first graph, for example, this fourth graph on the lower line, right? It is between petal width and petal width. So it's a univariate graph of petal width basically, right? So only one variable is there, right? So it's a univariate graph of petal width, right? So now on the univariate graph, we saw what is the univariate graph. It is basically my distribution plot, right? And a distribution plot, we saw two things. We saw the bars, basically my histogram bars, and we have the KDE, which is my run charts, right? So here, the option which was coming here, the diagonal kind, right, which is like the univariate graph, the kind of graph I want for the univariate variable, I can either plot a hist, basically bars, right? So bar kind of a graph, or I can also use a KDE. So these two options are there. I can do, you know what is a univariate graph for hist and KDE, right? We have already done that. So these two options are available for me, right? And now for the regular graph, for example, this remain apart from the diagonal kind, all the plot. Here I have option of scatter and the reg. Okay, so scatter is the most prominently used because it is more clearly visible in terms of how we can want to plot. So kind I'm using scatter here, and diagonal kind I'm using KDE, and palette I'm using hustle. So again I'm giving the color combination which I want to be part of my distribution kind of a thing. Okay. Now, so this is your graph, guys. Okay, this is your graph. Let me just zoom it a bit. Okay, so now this is your graph, guys. Can somebody tell me what are you able to figure out from this graph? Just tell me any two interesting inferences from this graph. Can somebody tell me any two interesting inferences? I am fine with this. Just look at this graph, okay? Just look at this graph, whatever is visible. So right now, these 12 plots are visible to you, right? Just tell me any one or any two inferences which you are able to see from this graph. Again, the reason why I'm asking this is, as I said, it is very important to read the graphs, right? So let's try to understand it. Let's try to understand how we can read the graph. Quickly, guys, tell me some of the inferences which you could figure out from this graph. Tell me at least anything. Anything, guys? What you're able to read? Tell me anything. So even the the problematic distributions are also fine. I mean, if you're not able to figure out, that's also fine. At least tell something. So okay, Mahesh has one thing: normally distributed diagonal graphs. Okay, yes. So now here definitely I could see based on different species I have different distribution, but again it's more or less pretty much normal distribution. But again here this petal length, right? So petal length does not look like normally distributed. So I have a huge peak for my Setosa species, and for the versicolor and virginica I have the smaller peak. So basically the range, the outliers, maybe the number of points which is highly concentrated on a smaller area is very high. So this is what we can think of petal length. So the range is lower for Setosa, but respectively for versicolor and virgicolor the range is higher and the data points are spread out, right? Basically kurtosis is high in petal length, right? So that's what we can see. Likewise in petal width also. Sorry. Petal width also I could see Setosa kurtosis is a bit high. So we have the data distributed on a smaller range. Also, guys, anything else which you are able to see from this graph? I could see one very interesting thing here. So for most of my values here, right? So for example, petal length and sepal length here. Can you see the values of Setosa species is on the lower side always, right? So can you see this? There's a clear distinction of my clusters, right? So I could see a separate cluster for Setosa everywhere, and that is the reason why. And also they're on the lower edges. So for the Setosa species, the petal length, petal width are very small. It's a smaller species, Setosa, compared to versicolor and virginica. Can we see that, right? So we could see this. So the ranges of the values of the Setosa species is very small, right? These are the smaller species. I could see that, and here I could definitely see that virginica is the one which is the most prominently big, right? So the sizes, the dimensions of my virginica species is comparatively very higher if I see the interaction also, right? That's one thing I could see. And also I could see a very positive correlation between my virginica and versicolor species in terms of my petal length and petal width, or also for the sepal width or somewhere it's still fine, right? And I could see that yes, as long as my one variable is increasing, other is also increasing. But on the other hand, for Setosa, this is not true, right? It's more of a flat distribution. So it is not following any contrary correlation as such. It's more of a haphazard, non-correlated data, right? So that is something which I could see from the graph. Anything else, guys? Are you able to understand what I'm trying to convey here? Right. So now the problem is it's still comparatively easier to plot as much complex graphs as you want, right? But still it's important to understand what does that graph telling you. Okay, that is something which is very important. So always try to understand that. Okay. So pretty much about my numerical data. Moving ahead, now plotting the categorical data. So how you going to plot the categorical data here, right? So as I was said, Hexbin plots and KDE plots which are used to analyze the continuous variables under study. So here we're going to be using strip plot and swarm plot for categorical data. Okay, so now till now we are plotting only the numerical values, right? So all the numerical values are getting plotted, right? But here we're going to be using strip plot and swarm plot. So two different plot categories, strip plot and swarm plot for my categorical data. So even for the categorical data like Setosa and all, right, we have to plot something. So we'll see how we can plot this. We'll look at that. Okay, we have one response from Vasanta, and there's most commonly used palettes in Python, sir. Okay, it depends again. So again, it's pretty much dependent on the user. So I mostly use Hustle, and I use greens, I use blues, I use BRBG. So Twilight I use. So again, it depends. I mean, more you practice, right? So more comfortable you will become with the plots, and then eventually you keep on remembering them also, right? So you'll become. It's not like it's generally common. It is very much dependent on the user also, right? So that's how it is. So now look at so now I'm trying to plot the strip plot. Okay, so I'm starting with the strip plot. Strip plot is nothing but is used when one of the variable under study is categorical. Okay, so here it's important that one of the variable has to be mandatorily a categorical variable. Okay, it represents the data in sorted order along any one of the axes. I'll tell you what do I mean by this. So now look at this graph. Okay, so I have, as I said, one of the axis has mandatorily to be a categorical column. Okay, and here I'm giving X as my categorical column. So species becomes my X axis, which is the category column, right? Now on the Y axis, I'm giving petal length, which is my number, right? So this X as a species and Y as petal length, I'm trying to put up the things in terms of my species as a category and the petal length as my variable. So now what does a strip plot looks like? So in the strip plot, we are trying to plot all the points allocated in this region for my three different categories. So for Setosa here, what is the petal length generally? So can you see this? The petal lengths are on the lower side. It's an increasing trend. So as long as we're changing the species, the sizes are very distinctive, right? So the range of my setosa is between 1 and 2. For the versicolor is between 3 and 5. And for virginica, it's between 4.5 to 7, right? So that's what the range is. So I could see a clear distinction of my species. I can identify that, right? So this is what my strip plot is showing. So here, what is my interaction is saying? Categorical versus numerical. So one of the column, one of the axis has to be a category column here. So, and here the category is species, right? And I'm plotting it against my numerical column, so it could be any numerical column. So right now we are plotting with petal length. We can also check it with sepal length, sepal width, so whatever we have. So that's not going to be a problematic thing. Okay, so that's what my strip plot says. Now another alternative, which is almost a similar graph, I'll tell you what do I mean by this. So here, instead of strip plot, I'm using a swarm plot. Okay, so same data, so same thing, everything. But look at the difference. So here in strip plot, what happens? The meaning, the inference is almost similar again. But I'll tell you the basic difference between strip and the swarm plot. Okay. So in the strip plot, you are seeing that the points. So basically, it's a scatter plot only. So the dots are basically my scatter plots, right? So here, these dots are getting overlapped. Can you see this? The dots are getting overlapped eventually. So for the smaller ranges. But in swarm plot, all the individual points will be plotted. All the dots, you can literally count the dots, and if you count it, you will be able to find out how many individual data points are getting plotted. You can actually count the plots also, count the dots also. Okay. And now here, if my breadth is more, so basically here you can see this, in this range my data is fanning out. That means that we have more number of observations where the value is exactly, say, 1.5, for example. So 1.5 with petal length as 1.5 for setosa is very high. The frequency of such petal length is very high for setosa. You got it? So that's what it says. So it is a very interesting graph if you want to find out if a particular point, if a particular value is being represented very oftenly, right? So that's when swarm plot is used. But on the other hand, strip plot is still giving you more of an overview sense of how distinctive my clusters are, and how shorter the range is. So this is what my business inference from strip plot is. Okay. Any questions on strip plot and swarm plot, guys? Any questions, guys? Anything which you want to talk about? Any questions? Are you able to understand the topic here? Are you able to understand what we're trying to say? Vasanta, Mahesh, Akash. Guys, quickly, is it making sense? Strip plot, swarm plot? These are on the other hand, I would say yes. So for example, setosa here, it's not a histogram kind of a thing, because histogram we're making the bins, right? Yeah, so in here we're not making the bins, but kind of I would say yes, for the like it's still giving me the observation frequencies, right? So where more numbers are being present. So yes, so information wise I would still say somewhat yes, individual for individual categories, but again there's a huge distinction between my histogram and my swarm strip plot, right? But again, I'm trying to get your point. You're actually right. So we're still using not the count, yeah, so kind of a count or a frequency here, so it's still giving me the similar information, but in a different way, right? So that's what strip and swarm plot does. Okay. Okay, now proceeding ahead, so we have the Seaborn distribution of my observations. Okay, so I mean, but again, I think we should really take a pause here. Any questions, any concerns, guys? Anything which you want me to cover? Are you able to get what we are doing here? Is it making sense? Anybody is having any concerns of whatever we are doing in this case? Mahesh, Vasanta, Akash, any questions, guys? I hope it's making sense to you guys. Cool, great. So pair plot once again. Okay, pair plot. I have a question from pair plot from Mahesh. Let me try to take that. Okay, so pair plot is again nothing but a kind of a graph which is giving me the interaction study between my numerical to numerical columns. Okay, so here the numerical columns, so as I was saying, so there are multiple interactions, right? So numeric to numeric, numeric to categorical, categorical to numerical, and categorical to categorical as well. So here this pair plot is talking about my numeric to numeric interaction, right? So I have sepal length, sepal width, petal length, and petal width, right? So we have 4 different columns available here, and in terms of my numbers, and now we are trying to find out how exactly these 4 are interacting, right? So here the objective is to try to plot the interaction between my all of my variables. And what are my variables here? So sepal length interaction with all, sepal width, petal length, and petal width. Likewise, sepal width interaction with all of the remaining 3 columns, sepal length, and petal width. Likewise, one column interaction with all the remaining other columns. So that's the objective. That's what we're trying to do here. Okay, in pair plot. So now look at this. So here we have 4 columns, right? So 4 columns will be plotted in both the x-axis and the y-axis. Now the interactive study would be done on each of my plots. So for example, the first graph here is between sepal length and petal width. Okay, so petal width will remain for this row. For the lower row, the y-axis will remain petal width only, and the first graph would be sepal length and petal width. The second graph will be sepal width with petal width. So likewise, all the interactive study will be happening for all the columns. Okay, now yes, so petal width will be plotted also against the petal width, right? So here in this case, this part becomes my univariate graph, right? So univariate graph in terms of the only single variable we have. So for this single variable, we understand. So for the univariate graph, we did the histogram, like the distribution plots, right? So for the distribution plots, we see how the data is distributed. We have 2 options in this case. We either can see the histograms, like the bars we saw, the rectangular boxes kind of a thing, or maybe we can look for a KDE, like a run chart, like a trend chart, right? So both of these we have seen that. So both of them are pretty much available. So that's what pair plot says. Mahesh. Okay, we have a question from Abhishek. Can you guide me for data science? I have learned basic Python, NumPy, Pandas, Matplotlib, Seaborn, and currently I'm watching your NLP lectures. After that, what I have to learn for data science? Okay. See again, Abhishek. So for data science, as I have always been saying, there are certain core technical skills. Okay, those are statistics, machine learning, Python, and SQL. Okay. So statistics is going to be the base of every data science job, whatever you are getting into. So data science job ke liye statistics is the base. Okay. So for statistics, there are numerous topics, right? So unfortunately, I haven't started with statistics anywhere. So statistics is something which we have a plan to start, right? So, but again, just to tell you guys, we are starting pretty much a new course on Geeks for Geeks starting from 9th of April. That is where I'll be covering everything in a very structured format. Okay, so that is a pure dedicated course spread across in 10 weekends. Okay, so that will be running only over the weekends. So per weekend, so you'll be having Saturdays and Sundays. So you have to give at least 3 hours per day. So 3 hours on Saturdays and 3 hours on Sundays. So totally 20 classes spread across 10 weekends, and 20 into 3. So that's going to be your hours. That's going to be 60 hours. So that particular course we're going to be calling as Data Science Live. Okay. So in that Data Science Live, that is where almost all the needed skills which is important for your data science journey, right, will be covered. Okay. So that includes your Python information, that includes your topics in machine learning, basic and advanced. That involves some really cool, kind of projects, including your latest day-to-day technical projects from industry level projects. And also we'll be doing some advanced things on deep learning. We'll be covering computer vision. We'll be doing some deep learning basics, advanced. And then also we'll be doing web scraping. We'll be doing things on web scraping. So a lot of interesting things are being covered in that particular course. So guys, so do remember that's a course starting from 9th of April. So I believe that's going to be your answer to your query, Abhishek. Okay, so that particular course which we're starting on from 9th of April, Data Science Live. And I'll be teaching you data science live for another 10 weekends starting from 9th of April. That is when you will be having a clarity of what still we can look out for from the course. Okay. But again, as in a nutshell, stats, ML, Python, SQL, that's what we have to focus on. And NLP, machine learning, Matplotlib, Seaborn, these are some of the other topics, subtopics of each of these, one of these mandatory skills, right? So that is what we have to look forward to. So again, guys, just to remind you again, so we are starting a new course starting from 9th of April, Data Science Live. So do look for the promotions on that. Do look for that course curriculum in detail, and you'll understand the importance of it. That's going to be spread for 10 weekends, 20 classes, 2 to 3 hours in a day, dedicated question answer session. So, and also we'll be running you through the codes. So all the needed tools and tech which you need for your day-to-day job in data science will be covered in that course, right? So that's going to be starting from 9th of April. Cool. So I think with this, we can stop for today. Okay, so I think we have covered some pretty good, interesting graph. If anybody is having any last moment questions, do let me know, or else we can pretty much stop for today, and then we can start from you know the graphs from. So okay, we have the distribution of observation on each category, so we can start with POC. So we have many things to cover, guys. Many things. So maybe we can take. I think 2 more days in Seaborn, and we're gonna be finishing. Seaborn is a very interesting topic, very, very, very interesting topic, and we have enormous amount of things which can be covered in Seaborn. Okay, so we'll see that, and we'll see how we can cover up the things. So we'll take maybe 2 more days, and then we'll cover the topics. Okay, so with this, guys, I'll pretty much take your leave, and if anybody is having any last moment questions, I'm pretty much happy to take that, or else we can wrap up for the day, guys. Any questions? Anybody's having any concerns? Any questions, guys? Any last moment questions? Okay, cool. So with this, I'll take your leave. I'll see you tomorrow, same time, 10 p.m. and we'll be covering the Seaborn graphs, and we'll try to cover within 2 days. So we'll try to finish Seaborn. Okay, guys. Thank you so much. Till then, stay safe and keep on learning. Thank you so much. Bye bye.